Hi everybody, this is Tim. I am here trying to make a little proof of concept video. Here we see Stebbins, as you may remember it. I'm going to click New Game to start a new game, and you can see the crud and the critters, and I'm going to do some hunting here for a while, and we're going to come back to this in just a bit. So what I'm doing is, of course, trying to get all the easily seen critters, and that's pretty good. And I can see I have 44 meals under my belt. We're going to keep going until we get to 50 and see what we see. There's 49 and 50. Okay, so I'm going to make a table and a graph, and in my graph I'm going to put meals on the horizontal axis because that's like time. And now let's see how green has changed. And what we can see is while we started with a pretty diverse amount of green, it has converged and gotten smaller, which makes sense because there's not a lot of green in this. And if I look at blue, I will see that we've converged a little bit, but it's a little bit more diverse. And let's see what the red situation is. It is also converged. Okay. So having done this, we're still wondering what's the game. And one of the things that we've talked about is possibly automating the predator. Now, in this video, I'm not going to talk about automating the predator, but we will get something that sort of looks in that direction. And that's going to happen with this new box here called Use Vision Parameters. And at the moment, if I click this, we can see the picture of the world change. Basically, what we've done is we've taken out all the green and all the blue, so I'm seeing only the red channel. I'm going to undo this so you can see back in the color. And this is controlled by this new panel called Vision. And there are two possible ways to do this: with a color response, that's what we're using, and with a black and white response, which we'll come to later. But just for the moment, I'm going to change this color response to be 0 red and 1 green instead of 1 red and 0 green. And now when I do the vision parameters, I see only the green channel. Let's see how that changes the way the game works. So I'm going to abort the game, and actually I'm going to reload the whole thing. And I'm going to use the vision parameters from the very beginning, and we're looking at pure red. Okay, now I'm going to be a hunter again, and I can easily see what the most salient, most easily visible critters are. And whoops, I hit part of the crud, and there's one, and already it's a little bit hard to tell which ones are the critters and which ones are the crud. So let me make a graph and a table, and I'm going to see, I'm going to put meals on the horizontal axis because we haven't even got to 10 yet, and I'm going to look at red and see how it's changed. And now I'm going to get data, and we can see already at 9 meals it's converged quite a bit. And you know, I'm in a little bit of trouble here. There's 10, there's 1, and I'm looking really hard. Oops, nope, I missed one. So here we can see that if the predator were blind to blue and green, this is what the predator would see. But suppose then the predator can change its vision capabilities. So now I'm going to change this again from red to green. And I'm going to go back to the world, and oh my goodness, I can now see some of the critters I couldn't see before. It's clearer which things are critters and which are not. So in fact, let's make another graph, and I'm going to put meals on the horizontal axis, and we're going to see what the path of green has been. And of course what we can see is it hasn't converged as much as red because we only saw red. Now green has a certain amount of variability to it, And if I continue to play with only green, I'm going to see a convergence in green. So that gives you some picture. Let's explore this just a little bit more. I'm going to make another new game. I'm going to go to Vision, and instead of just putting ones in one spot, I'm going to put one in both red and green and see what that looks like when I use the Vision parameters. Now, all of these colors are made up only of red and green, but no blue. Under the hood, what's happening is we have created a vector here, and all these numbers are supposed to be from 0 to 1, and this is red, green, and blue. And I take a dot product of this vector with the existing color vector of red, green, and blue. I'm telling you this because when we go to this next method, which is what we're going to do next, it works completely differently. In fact, let's now change to this other method right now. Here we have a formula that says red plus blue plus green divided by 3. And let's see what that looks like. So you can see it's black and white. It's entirely grayscale. What that's doing then is it's taking the quantities for red, blue, and green, adding them together and dividing by 3, that is, averaging them. In this case, I can have my world and I can continue to play just as I did before and find the critters that are contrasty with the background and with the crud and play that game. But suppose I had a different set of visions. So I'm going to abort this game. I'm going to create a new game, and I'm going to change the vision. Instead of being r plus b plus g over 3, I'm going to make it r plus g over 2. That is, just as we did up here, I'm just going to look at the red and green channels, but I'm going to average them together and use that quantity in each channel, red, green, and blue, in order to make grayscale. Now what I'm seeing is a colorblind predator who can only see red and green. And so now I'm going to go ahead and I'm going to do this for a while. Okay, I've now played this for 40 turns, for 40 meals. And here is what we see. Now I've created a graph of red against green. I could, in fact I should, make another graph. So let me make this graph for you. And we're going to do the traditional graph that we've used before. Here's meals, and I'm going to put red on the vertical axis. And we see that red has not converged. And I'm going to put green on the vertical axis. And we see that green has not converged. But all we can see is red plus green. And so in this graph, I've plotted red against green. And let me select all of the creatures from the beginning. And you can see that the selected points are sort of spread around the graph more. At 10, they're kind of down here. At 20, they're a little more lined up. And by the time we get to 40, they're lined up along this line. And this is the line where red plus green is about 12 or 13. And if I look at the background color up here, I see that red plus green for the background is in fact 13. There are a lot of creatures here which I can't see because they're identical to the background when seen with this vision. If I turn off the vision parameters, look to see what happens. Oh, look, there are all these bluish ones, but I'm blind to blue. I can't see them. Now I'm going to turn it off again, and you can see them vanish. I think that's very, very cool, because now we can ask, what's the formula that I need in order to be able to see these things? So if I have an option as a predator, even a non-automated predator, I can now go over here and say, oh, maybe I've saved up enough evolution points to change this entirely, and I can change this, for example, to be just blue. So I'm going to go back to the world, and sure enough, now I can see a bunch of dots I couldn't see before. Intriguingly, there's another thing I could do, is I could say, 15 plus red minus green, and you should look in the document to see why, and divide that by 2, and I'm going to go back to the world. And look how well I can see the dots. And in this case, interestingly, the crud is almost invisible. So we have this opportunity to think both about vision and about sort of designing your evolution in order to make it easier for you to find prey.